Okay, no, not to use so much of that space. All right, we're gonna hope this works. Okay. Hi, I'm Sam. I'm a student at Long Beach. Hi, I'm Sam. I'm a student that studies. Hi, I'm Sam. I'm a student at CSULB, Long Beach. I said Long Beach twice. Hi, I'm Sam. Shit. So I dedicated this channel to all the stuff that confused the shit out of me. So the concept we're going to learn today is focal length, and I did a little picture to help represent focal length and focal points. And we're going to go over some concepts regarding how cameras work and why focal points and focal length matters. So getting into where focal points and focal lengths come from, we have to study the eye. Now, I don't want to go into the specifics of the anatomy of humanity. Right. Now, I don't want to get into that because I don't study anatomy. For the sake of simplicity, we're just going to go with the necessary things that help us understand focal length and focal points. So we have the pupil. Now, the pupil is the opening into the eye which lets light in, and this can be best shown when the iris interacts with the pupil, making it bigger or smaller, letting in more or less light. That's for aperture, but we'll get to that in another episode, if you guys ask me. But anyway, the light comes in from the pupil, or comes into the pupil, and interacts with the lens behind the eye. Now, this is a convex lens. I'm not going to write that. It's a convex lens. And what the light does is that it bends it to the specific point and spreads it along all of these light-sensitive nerves, which go into this little brain thing in your back of your brain. It sends signals to the brain so that you can see. It interprets it as vision. Now, same thing with a camera. Okay, so what we have here is a simplified version of the inside of a camera. Now, for simplicity's sake, we're not going to talk about CCD or CMOS for the image sensor at the back of digital cameras, but this is going to be for film cameras specifically, which they use light-sensitive chemicals at the back of the camera. Now, what we have here is the lens, and we have the light-sensitive chemicals. Once they interact with the light-sensitive chemicals, then the image shows. Then we can see an image. It creates an image. And we can't do that without the light. So what the convex lens does is that it bends the light coming in. It makes it come in inward. So it goes like this. Bends it inward. If you couldn't tell, I did animation for 4 years, so I'm very smart at drawing. That's beside the point. The light bends inward into this specific point so that once it gets here, all the light reverts onto the image sensor and creates a perfect image. Now, what is created from this interaction, this is what we call the focal point. It's important because with the light being bent by the convex lens, it makes it so that proportionally, whatever the convex lens can see, it helps the light come in, more light come in, so that you can see more. you can get a wider field of view. So with all the light coming in from here, all of it gets bent to a focal point and proportionately can be distributed on the light sensitive chemicals, and that's when you get a clean image. Now, the length between the focal point and the image sensor, is called focal length. And we'll get to why that's important. So what we have here are the three most common types of lenses. We have the 23 millimeter, the 35 millimeter, and the 50 millimeter. The 23 millimeter can technically be a 25 millimeter. Doesn't matter. The point being, it's a wide angle lens. This is a normal lens, telephoto lens. Yeah. All right. Now what they're characterized by is their focal lengths. The focal length being 23 millimeter, 35 millimeter, 50 millimeter, and this is optically. So, because I've seen wide lenses that are have a longer barrel than, say, the telephoto. But optically, that's how it would be. The equivalent of how far is the focal point from the image sensor or the light sensitive chemicals. So for a wide angle lens, the distance is very short. The distance is very short. So the effects of a convex lens, they're more apparent. So you get this thing where at the edges of the convex lens, the light is stretching itself very far, more radically than the light coming in just straight. So the edges of the frame are going to be stretched out, and the depth it'll look wacky. That's the best way I can describe it. It's stretching the light so that it can fit onto the image sensor. So that's very apparent with the wide angle lens. And since the light doesn't have to travel so far as well when it comes to focal length, it also means that all the light is very sharp. So if you're shooting something that needs a lot of depth and you need to capture a more wide angle, that's why it's called the wide angle. Y'all so smart. It's called the wide angle because you have a wider field of view and all these effects are at play. So for the 35 millimeter, it's considered the normal lens because it best reflects how our eyes work. It's just going to look like what we see. So that's self-explanatory. It is the most similar to us. Now, with the telephoto lens, the focal length is longer. It's longer. So the light that's getting stretched has to go a little bit farther. And so, if you can see, the light coming in from the wide angle lens to meet its focal point, it's going like this. It's at like a sharp angle. Meanwhile, the telephoto has more time to get to the focal point. So it's not that curved, it's like this. One's at like a 45 degree, and then the other is more like a 20 degree. I know my degrees. I did math. But because of this, there's also effects that it has on the image. So, for one, the effects of the convex lens and how light is stretched aren't as drastic. So, the sides of the image aren't going to stretch. Everything's going to be more narrow, and you'll have a lesser field of view, actually. So as you go up in focal length, you see a reduction in field of view. Interesting, I know. because the light coming in is more narrow. Not only this, but because the light has to travel a greater distance, it's not going to be as sharp. So you're going to have a shallower field of depth when it comes to a telephoto. Which is why when working with depth, this is the easiest one to capture everything in deep focus. And this is the hardest to do deep focus because it's practically impossible. But you could try. But semantics aside, I don't know what the word semantics means. Please comment that if you know what that means. But so these are the three most common lenses, and that's the reason why focal length matters. It's because it affects the effects of the camera. And you achieve different effects when it comes to different focal lengths. Now, I hope you all enjoyed. I had a lot of fun recording this in a bathroom, but if you want to see more of this, or you have any concepts you want me to teach, I'd be glad to. I am having a lot of fun. Without further ado, this has been Sam. I don't know what to call this channel yet, so we'll figure that out once I publish it. Cheers.